Okay, question 1. So what's the partial derivative? So now the function has two input variables, x and y. Okay, so you can change both variables and then the function's value will change. Okay. The idea of the partial derivative is that if you fix other variables and only change one variable, then how will the value of the function change? Okay, so for example, fx, which you can also write it as df over dx. Now notice that for the partial derivative, we use the curly d. Okay, we don't use a normal d anymore. We use this curly symbol. Okay, this means if you only change x, okay, you fix all other variables. So in this case, there's only one other variable, which is y. Okay, you fix y, right? So y is fixed at a certain value. Then how will the function value change when you change x? Okay, so since y is fixed, so now you can treat y as a constant, right? So essentially, you are trying to differentiate this by x when you treat y as a constant, for example. Okay, so now you have to use a chain rule first. E to the power of something, the derivative is e to the power of something, then x squared times y. Okay, if you treat y as a constant, then the derivative is 2x times y. Okay, it's going to be the derivative of this. And then minus, so this part, if you differentiate this, again, use the chain rule, x minus 1 to the power of half, the derivative is 1 over 2 square root of x minus 1. Okay, then x minus 1, if differentiated, it will be 1, so you don't have to write that down. Okay, so this will be the partial derivative of x by x. The partial derivative by y, you just have to do the same thing. Now you have to treat x as a constant. Okay, so if you treat x as a constant and try to differentiate this by y, the first part is still e to the power of x squared times y. And then the second part, you differentiate this by y, you treat x as a constant, you'll get x squared. Okay, then this part, okay, because you treat it as a constant, you differentiate the constant, you get 0. Okay, so this will be fy. Okay, this will be fy. So this is the first part. Part B. Now your fxy sine x minus y over y. Okay, plus x squared tangent y. Okay, again, if you differentiate it by x, df over dx, if you differentiate it by x, you just treat y as a constant. Okay, so this part, you differentiate sine, you get cosine, right? And because y is just a constant, so you can just leave it as 1 over y. Then this part, you differentiate x squared, you get 2x, and tangent y is just a constant. Okay, tangent y is just a constant. Okay, but now if you differentiate it by y, you have to treat x as a constant. Okay, then if you differentiate this by y, you are going to use a quotient rule, right? It's going to be bottom square, the top's derivative. So the top's derivative, now you have to use the chain rule because x minus y, right? You differentiate it by y, you have a extra negative 1 in front. Okay, so the top's derivative times bottom minus top times bottom's derivative. Okay, and then plus, so this part you treat x as a constant, you just need to differentiate tangent y. Tangent y, what's the derivative? It is second y squared. Okay, so that would be the partial derivative by y. Okay.